So welcome to the video on graphing the reciprocal function. Now what the reciprocal function is, it's basically a rational function, but it's one of the most simplest rational functions because you usually have a polynomial over another polynomial, but all you got here is just an x on the bottom. So it's not like a trinomial and then like a binomial top or anything like that, okay? So this is the most basic rational function as far as graphing goes. And we're just gonna go through this video and show you how to do it. All right, so just starting off, just like with most other functions we've worked with, this does have a parent function. That's the most basic of the functions of that family. So this is the parent function. And then you have a general form of the function so that it can help you see how this thing gets shifted around. So you got an A, H, and K value here. And basically these all do different things. Now, we've done this type of form before. If you kind of recall from the past, we've had this in the x squared. So with quadratics, we've had it with absolute values, cubics, square root functions, more recently with exponential functions, as well as log functions. So we've done all this graphing in class before. And these all have A values, they all have H values, and they all have K values. And basically, if you know what all these values did with any one of these in the past, you should be in pretty good shape for being able to know what they do with what they're going to do with this reciprocal function right now. Now, let's go ahead and build the parent function graph so we can see how this thing came about. Um, Now, normally what we do is we start plugging in values for x. So just start at x equals 0, then you go up 1, 2, 3, then you go down -1, -2, -3, and then just plug those values in. So you get your inputs and then get your outputs. So if you plug in a 3, you get a 1/3 because 3 goes in for x. You plug in a 2, you get a 1/2. 1 is a 1. 1 divided by 0 is undefined. 1 divided by -1 is a -1. Then 1 divided by -2, 1 divided by -3. So the way I got these x values is normally when you're starting with the parent function, you want to start at 0. And like I said, just go a few up and a few down so you can get a general feel for the shape. Now, this one is kind of unique because when you plug in a 0, you basically you don't get anything because it's undefined because you're not allowed to divide by 0. Now, plotting those points looks like this. Um, this type of graph actually has a special feature on it that we have not seen before. So far, we normally just work with one asymptote, but with these functions, you actually have two. So there's two numbers that this graph will not touch. And keep in mind, these dashed lines mean that these lines are not actually a part of your graph. They just help you draw your actual curve. So so on some graphing software, you won't even see these dashed lines. All you're going to see is like the actual curve itself. It's kind of like scaffolding on the building. It just helps you build it, and then after that, you can actually erase them if you wanted to. Most teachers want to see them though, just because we want to know that you know that that they're what they are and where they're at. All right, so we have two asymptotes. First one is at x equals 0. Next one is at y equals 0, and I'll show you how to figure out where to place those. Your horizontal asymptote, which goes side to side, and your vertical asymptote, which goes up and down. Now, when you actually connect your dots, it goes like this. So you want to stay in those because if you think about the asymptotes, you're not supposed to actually cross over an asymptote. Your graph never should touch the asymptote. So these 3 points are right here. You would just start really close to it, hit all 3 of them, and then get really close to this one. And you kind of do the mirror image of it on the other side. Okay, and then that's basically your parent graph. All the graphs that you're going to make as far as the reciprocal function goes are going to look very much like this. You're going to have one on each side and then two asymptotes. So this parent function, and then like I said, we have a general form, which we're about to get into. And then basically we're going to have A, H, and K values and kind of explore how those affect this general shape of the graph. So let's kind of pull that off to the side. So we have our parent function over here while we go over some key features that you're going to have to be able to find and identify as far as this reciprocal function goes. So first off, the vertical asymptote that I was talking about, that's this one going up and down. That's pretty easy to figure out where to place that. All you have to do is actually look at your H value. Whatever your h value is, that's your vertical asymptote. So if your h is a 5, then you're going to go out to 5 and put a vertical asymptote there. If it's a 2, you're going to go out to 2 and put a vertical asymptote there. You're only going to have one number on your h values, so you just got to find that out and then place that. Similarly, with the k value, so if the h value gives you your vertical asymptote, the k value gives you your horizontal one. So that is your side to side one. So whatever your k value is, if your k is a 2, you're going to come up with 2 and put a horizontal asymptote going side to side. All right. Couple more things to kind of know about. Since we figured out our asymptotes, like I said, are basically the values that your graph will never touch. So if we think of this x equaling h, that's actually going to be, that'll actually tell us our domain, what number our domain is not allowed to touch. So since my graph doesn't touch this, my domain will not include that. So my graph never touches h, so my domain does not include h. So my domain is all real numbers except for this h value, because like I said, this dashed line is where it does not touch that. Um, from that same kind of logic, that's how you get your range. Your range, since you have a vertical asymptote that your graph never ever touches, then your range is all real numbers except for that number that it never ever touches. So except for k, because k is where it doesn't touch. So you can pull a lot from your h and k values, vertical asymptote, as well as what your domain does not have in it, horizontal asymptote, as well as what your range does not have in it. Okay, a few more features here. X-intercepts. Now you find your x and your y-intercepts actually the exact same way you do with any function that we work with. If you want to find an x-intercept, you just plug in 0 for y and then solve for x, and that's your x-intercept. Same thing with your y-intercept. If you ever want to find your y-intercept with any function, you plug in 0 for your input for your x and then solve, and then that'll be your y-intercept. So if you these problems are going to ask you for these, so just be able to do that. It's just simple solving. Well, not simple depending on how much you remember from the other chapters, but it's just solving equations that we have seen in the past once you plug in the 0 part. So that's not anything really new. As far as transformations go, because you will be asked around how to transform these things. As far as transformations go, make sure you know your A, H, and K, and then these act just like they did in the past with quadratics and so forth. The A value does vertical stretching, vertical compression, and reflections over the x-axis if it's negative. So vertical stretch is if A is bigger than 1, compression if A is between 0 and 1. And then if it's a negative, like I said before, it's reflection over the x-axis. What does H do? H is a shift left or right. Another way to say that is a horizontal translation. These mean the same thing. I think in our class, most people have been saying shifting. And just remember to shift your sign. It says x minus 5. Your H value is actually a positive 5. So that's what this little minus sign means, is that you're actually doing the opposite of whatever you see here. So just make sure that with the X, you switch the sign. And then K value shifts it up or down, also known as a vertical translation. All right, so steps to graphing this thing. So first off, the steps that I'm about to show you might be different than what other teachers show, but this is the way that I found most of my students understand it. If it makes sense to you another way, feel free to do it that way too. Just make sure you're able to get that main information that I just mentioned. So first step is to find A, H, and K. Second step, identify and graph both of your asymptotes, the vertical and the horizontal. After you have those asymptotes on the page, you just got to figure out where the points are so you can start figuring out what your curve is going to look like. So your input output table, though, I taught my classes how to do like a triple table, an A value table, and an HK value table. But you can actually just start on the last table and just make sure that it's around your H value and plug that into whatever equation I give you. So I'll show you what that looks like in a second. And then after you have your table, you're going to plot the points and draw a smooth curve, 2 of them, because remember, it kind of looks like 2 separate exponential functions. All right, so first example. So we have y equals 3 over x minus 2, and then we're adding 1 to it. So what I like to do first is find a, h, and k. So my A value is 3. H value is a positive 2, even though it says minus 2. You're supposed to switch the sign. And your K value is a 1. Now, once you have those, you can very easily find your asymptotes, right? So your vertical asymptote is 2. It's whatever your H value is. And your horizontal asymptote is your K value. One way to memorize this, figure it, because it's not too difficult to figure out, but you can get mixed up pretty easily in that just mixing up what H and K goes with which one. So what I like to do is just think of alphabetical order. X comes before Y, just like H comes before K. So X goes with your H's, Y goes with your K's. So just think of alphabetical order. So the first ones come up first, second ones come up with the second. So K goes with Y, H goes with X. All right. So now that we have our vertical and horizontal asymptotes, let's go ahead and graph those. Vertical asymptote is at positive 2. So that's my vertical asymptote right there. Horizontal asymptote is at y equals 1. So at y is 1, we're going to make a side-to-side line. And there you go. So now all I got to figure out is, okay, when I make my curve, is it going to be here and then the mirror image is on the other side over here? Or is it over here and then mirror image over here on this other side? And then some points to kind of make it nice and neat. So go ahead and start making your input output table. Now I did 5 cells. I'm going to start around my H value. So I'm going to start at 2. Um, and then I'm going to go up a couple and down a couple. So remember this 2, just figure out what your H value is. That's where you're going to start. Now that starting point is always going to be undefined because since you're starting at H and that's your asymptote that doesn't have any values, that's why it's undefined. So if you think about it, you plug a 2 in here, 2 minus 2 is 0, 3 divided by 0, you're not supposed to do, and then that falls apart from there. So even though I say put 5 points, this first starting point is just to kind of figure out where the center or quote unquote center of your graph is. Right. And then now just start plugging these into your equation that I gave you, and that should start giving you some answers. So if you plug a 3 in there, 3 gets plugged into here. 3 minus 2 is a 1. 3 divided by 1 is 3, plus 1 is a 4. Plug a 4 in. 4 minus 2 is 2. 3 divided by 2 plus 1 is 2.5 or 2.5. I don't mind if you use decimals. It's up to you. Plug a 1 in, you get a negative 2. Plug a 0 in, you get a negative 0.5. And then, so we made our input output table. Now let's go ahead and plot those. So we're going to plot them and then draw a smooth curve. So here are those points on the graph. So there's only 4 of them, remember, because this middle point, I can't plot that because it doesn't exist. 2 is right here, and I don't have any points that are even supposed to touch this line. All right, so now that I have my points, just draw your curves, right? And that's it. You have your graph. Now, the problem might ask you for other pieces, though. So I'm just going to move this information over here. So I'm just going to move the AHK and the equation over. If it asks for domain, keep in mind your domain is everything except for your H value, because that's your X value that it doesn't touch. Domain go with X's, so that's why this H was in there with your X's there. So X equals 2 is your asymptote. Your range is every number except for your K value, so except for 1. Another thing that they might ask for is x-intercepts. So remember, take the x-intercept, you're going to plug a 0 in for this y value. So y turns into 0. And now you just solve it out. So first step to solving this is to subtract 1 from both sides. I have x minus 2 on the bottom, so I'm going to multiply both sides by an x minus 2. Negative 1 times an x minus 2 gives me this. And then I get, just keep solving. Add 2 and then divide by negative 1. X is not, or x, your x-intercept is negative 1. So if I take a look at my x-axis, negative 1 is right here. So that kind of verifies that. Now on this one, I probably could have just looked at the graph and saw it. But the thing is since I didn't actually plot that point, that's kind of an eyeball. Like if you're drawing this curve and you miss that by a little bit, it might not look like it. So the only way to get kind of exact is to actually do the algebra. You can use your graph to kind of to see if your answer is around where you would think it would be though. All right, so there you go. So x equals -1 is right there on the graph. Forgot I put that animation in there, so I didn't have to explain that. Y-intercept, same thing, but instead of plugging 0 in for y, we're plugging a 0 in for x, and then now we just evaluate this right side. So you get 0 minus 2 is a -2. 3 divided by -2 plus 1 will be 0, -0.5. And then if we take a look at our graph, y-intercept is where our graph crosses the y-axis, which is about right here. We actually already had a point there. So if we pulled back up the table, we would see that that was actually in there already. All right. And one more thing, transformations. Just make sure you're able to identify any transformations from the parent graph. Remember, A, H, and K will tell you what that is. So since my A is a 3, I have a vertical stretch of 3. Since it's bigger than 1, it's a stretch. My H value is a 2, so it got shifted right 2. And my K value is a 1, so it got shifted, oh, not down. This should say up. Got shifted, just ignore the down. Up 1, it's going up 1. Okay, so let me get that off the screen. Okay. So quick recap. We have to know how to graph. That means making your table, graphing your asymptotes, and then just be able to identify the asymptotes. Vertical is always going to be x equals, horizontal is going to say y equals some number. Domain range, x-intercept, y-intercept, as well as transformation. So a lot of different pieces here, but a lot of them are related. So vertical asymptote is directly related to your domain. Horizontal asymptote is directly related to your range. X and y intercepts, I mean, that's stuff you've done in the past, and transformations you've done in the past. So not really new stuff. It's just that we're mixing old knowledge together in a different way. All right. Okay, so let's go ahead and do some DocCam examples. And we'll just keep this right here. Find AH and K, identify your asymptotes. So I'm going to follow these steps. And on here, I actually already have what normally they're going to ask you around. So with this first example, we have something a little bit new that we did not see in the PowerPoint example, which is this negative. Now, this negative out front is the same thing as putting the negative on the 2. So I'm going to go ahead, my first step, I'm going to go ahead and move this negative up to that 2 right there, just so that it's clear what my A, H, and K are. A equals, H equals, and K equals. First step is to find A, H, and K. So this negative, if you see a negative out front, go ahead and plop it on the top, the numerator, so that you can see that this negative is actually with that A value. So A is a -2. H, so I see X minus 3, but remember you should switch that sign so H is actually a +3, and your K value is a 4. All right. So I found A, H, and K. So that was the first step over there. Now I'm going to identify and graph both asymptotes. So VA is vertical asymptote, HA is horizontal asymptote. So just remember vertical and horizontal asymptotes, that's going to be your H and that's going to be your K. So vertical asymptotes are always going to be X equals. And then that's going to be 3. Horizontal asymptote is going to be Y equals 4. All right. So let's go ahead and graph those. So X equals 3. So I'm going to go out to 3. 1, 2, 3. And I'll put some resources on this video so you can download some free graph paper if you don't have any at home, and make this a little bit easier. And Y equals 4 is my horizontal. So I'm going to go up to 4. And I'm going to make my horizontal asymptote. All right. So there goes your vertical and your horizontal asymptotes. So now my graph's either going to exist here and here, so or here and here, and I won't know for sure. Well, actually, you can tell because of the negative, but let's go ahead and since we have to make a table anyways, We're done identifying the asymptote, so let's go ahead and make our table. So our table, got our x, we got our y. All right, so our table, our starting value is going to start at our h. So our h is a 3, so I'm going to start my table. Right in the middle is going to be the 3. Okay, so if you think about this graph, that's my point right there. That's why I'm starting at 3, because I want to test a couple points to either side of that vertical asymptote. Okay, so 3, 4, and 5, 3, 2, and 1. So what I'm going to do now is I'm going to take this 5, plug it into here, and then get a y value out. So if I plug a 5 in here, that's 5 minus 3, which is 2. Negative 2 divided by 2 is negative 1, plus 4 is a 3. Plug in a 4. 4 minus 3 is a 1. Negative 2 divided by 1 is negative 2, plus 4 is 2. If I plug a 3 in, 3 minus 3 is 0. I'm not supposed to divide by 0, so that is not even there. It's undefined. Okay. Plug in a 2. 2 minus 3 is a negative 1. Negative 2 divided by negative 1 is a positive 2. Plus 4 is a 6. And then last one, plug in a 1. Minus 3 is a negative 2. Negative divided by negative is a positive. 1 plus 4 is a 5. All right, so those are your points. And let's go ahead and plot those. And we'll plot them in green. So we got 5, 3, 4, 2, 2, 6, 1, 5. There's only 4 points to plot. So 5, 4, 5, 3, 2, 3, 4, 2. Okay, so there's those two. I got 2, 6, and 1, 5. So 2, 4, 5, 6. And 1, 5 is right here. Okay, so I got my points. And remember, when you connect these things, I'll connect it in blue. When you connect these things, start really close to your asymptote. So you go through both of them and then get really close to your other asymptote. Okay, same thing here. All right. Now, if you wanted to, since I know that we're eventually finding our x-intercept and y-intercept, you can wait until you find those two and then plot them on here. I always like to draw it first, though, just so I can kind of make sure that when I'm solving my x and my y-intercepts, that it's around the general area that I'm seeing my graph cross. So I'm using this as kind of like a double check to make sure I did my x and my y-intercepts correctly. But basically, we're done graphing. So as far as the graph goes, it says plot 2 points or plot points and draw a smooth curve. We just did that. So this is our graph. But since the problem is asking for other information, now we have to analyze our graph and get this other information out. So let's go ahead and do that. So we got our domain. Our domain, there's different formats that you can write this. You can do set notation, you can do interval notation. I'm just going to write all real numbers. It's supposed to be x such that it's all real numbers, but all real numbers except x equals 3. Okay. All real numbers except x equals 3, or all real numbers except 3. So same thing with range, except y equals 4. And what I see sometimes is some teachers show it like with a little cross through, like y cannot be 4. I'd be good either way. Technically, that's kind of like a double negative since you put except already here. But either way, as long as I get an idea what you're talking about, I'm okay with that. Any math teachers are watching this, they might be cringing at me saying that, but it's fine. It's fine. So x-intercept. So let's find the x-intercepts. So that the way the x-intercept works is, let me show that work over here. So my x-intercept, I'm going to plug in a 0 for y. So y is a 0 equals negative 2 over x minus 3 plus 4. Now, if I look at my x-intercept, it looks like it's going to land somewhere between 3 and 4 because it should be right around right here. So if I saw this out and it's not somewhere between 3 and 4, then something might be going wrong here. So first off, let's go ahead and subtract the 4. So you subtract 4 on both sides. You get negative 4 equals negative 2 over x minus 3. I'm dividing by x minus 3, so I have to multiply both sides by x minus 3. So I'm going to multiply this side by x minus 3. These two are going to cancel off. And I get negative 4 times this, so that's going to be a negative 4x plus 12 equals negative 2. All right. And then I'm going to subtract 12 from both sides. So I get negative 4x equals negative 14. Divide both sides by a negative 4. And x is equal to positive 3.5 or 3.5, which is what we kind of thought was. It was going to be 3.5, which is right here. So we actually have another point right there if you want to put it in there. So my x-intercept is 3.5. Okay. Now let's do our y-intercept. Now your y-intercept looks like it's crossing right between 4 and 5. So let's make sure that when we do our y-intercept, should be between 4 and 5, and we should be good. So y-intercept is y equals negative 2 over 0 minus 3 plus 4. All I'm doing is I'm plugging in a 0 instead of my x right here, and then I'm going to solve for my y. That's my y-intercept. So y equals negative 2 over negative 3 plus 4. That's going to turn into positive 2/3 plus 4. So y is equal to 4 and 2/3. So that's between 4 and 5. So yeah, that looks good. If you want to turn into decimal, that's going to be about 4.67, 6 repeating. And yeah, so that's my y-intercept. Y is 4 and 2/3. I'm good with either mixed number. You can even keep it an improper fraction, but since we're graphing it, it should at least be a mixed number, or decimal. That's fine too. As far as transformation goes, my Sharpies are taking up a lot of room on this page. So I will do this in red. Transformations, go back up and look at A, H, and K. So A is negative 2. So I have a stretch, vertical stretch. I'm okay if you just put stretch. Stretch factor. And sorry, it's kind of going into my other work. Stretch factor of 2. Okay. Not negative 2. The negative will, what the negative tells us is that it has a reflection. And the x-axis, I'm okay if you just put reflection because we don't really deal with the y-axis yet. And also h is a 3, so it's shifted, and then h is a 3, so it's shifted right 3. And that 4, it tells me to go up or down, so this is shifted up 4. Okay, from the parent graph. So I got shifted right 3, up 4. That's why when we started off, we were actually right on the origin, and then it got shifted over. Okay, so that is the first example. And we got a few of them. And keep in mind, like I said in the past, you can skip around these examples. If you get that one and you feel like you can do the homework, feel free to do it. If you feel you need more examples, you can always come back to these videos. All right, so next example. So we have, this is in our AH and K form, our general form. So first find A. A in this case is a 4. H doesn't look like there's any H down here with the X, so it's going to be H is 0. And my K value is negative 3. All right, so I found H and K. Let's go ahead and identify my vertical asymptote and horizontal. So vertical goes with X equals. Horizontal is Y equals. So X's go with H's, so that's 0. Y's go with K, so that's going to be a negative 3. All right, so let me graph those real quick. So X equals 0 is my vertical, so it's going up and down. All right. And then, so it's right there. And then I got my horizontal, which is y equals -3. So it's down here at -3. And there you go. Okay. So I got my vertical, x equals 0, horizontal, y equals -3. All right, I'm to my second part, which is now, or sorry, my third part. So input output table. So we're just gonna kind of show how we get these different parts. Um, since I ran out of room on the last one, let's go ahead and do it right here. I think this is probably a better spot. So x and y. My h value is a 0. So I'm going to start my x values out at 0. I already know that's going to be undefined because that's just where I start. Every place where I start, the h values, once you plug it in, you're always dividing by 0, so it's not going to work out too well. So 0, 1, 2, -1, -2. So just plug these values in. So if I plug a 2 in, 4 divided by 2 is 2, minus 3 is a -1. That's a -1. If I plug a 1 in, 4 divided by 1 is 4, minus 3 is a +1. Okay, plug a -1 in. So 4 divided by -1 is a -4, minus 3 is a -7. And then plug a -2 in. -4 divided by -2 is -2, minus 3 is a -5. All right, so now I got my points. So let me plot my points. New color, 2, -1. So right 2, down 1. I got 1, 1. So right 1, up 1. Starting from the origin, right 1, up 1. I'm going to go ahead and just draw this right now. So coming across those two, and then across that way. Okay, -1, -7. It's way down here. Okay, and then I got a -2, -5. And that's right there. All right, so start close, come up, hit both, and then go this way. All right, so that's it for the graph. Now I gotta identify all these other pieces up here. My domain is all real numbers. And instead of putting except, you can say x cannot be 0. So all real numbers, but x can't be 0. Range can be any number you want, except for your y cannot be -3. Okay. Again, there's different notations out there, and that's probably horrible for me to be doing that, but it's fine. It's fine. Okay, so x-intercept. Let's do this up here. So if I take a look at this, my x-intercept is where my graph crosses the x-axis, which looks like it's right here. So that's between 1 and 2. Looks like 1.5, but somewhere around there. So let's go ahead and solve it out, see what we get. So x-intercept, let me do this in another color. It's in green. So x-intercept, it's going to be when y is 0. So 4 over x minus 3. And then solve for x. So I'm going to add 3 to both sides. 0 plus 3 is a 3 equals 4 over x. Now my x is in the denominator, so I can multiply both sides by x. Those go away. I get 3x equals 4. Divide both sides by 3, so x equals 4 over 3. X equals 1 and 1/3. So 1 and 1/3, which is about what we said. So there's 1 and 1/3. It's about right. Close enough. So x-intercept is 1 and 1/3. Let's do our y-intercept. A lot of work, huh? So we got y equals 4 over x minus 3. We're going to add 3 to both sides. Whoops, sorry. Y-intercept, that should be 0. X is 0 for your y-intercept. Now, if you notice 4 divided by 0, that's not going to work. which is the reason why, if you look at your y-axis, it's actually our asymptote, which our graph does not even touch. So we don't have a y-intercept because you can't have a y-intercept if your graph never touches the y-axis. So none. Okay. Now, you don't necessarily have to show this work. If you can show, like, if it's clear from your graph that there's not a y-intercept and you just put none here, that's fine with me. So none. Transformations, last part. Look at your A, H, and K. So since my A is a 4, I have a stretch factor of 4. H is 0, so I don't have any left-right shifts, but K is a -3. Since K is a -3, I know that this is going to be shift down 3 for my transformations. All right, and that's that one. And then one last one, just a real quick one, hopefully. This is getting to be a long video, but again, it's broken into smaller parts, so you can always skip around to the different examples. Now, this one's a little bit different in that it says xy equals 2, but if you look at our general form over there, that should say y equals. So my first step here is I got to get the y by itself. So if your y is not by itself, you need to get it by itself, because otherwise it does not look like this form, and it's going to throw everything off. So this is actually the same thing as those x's are gone. So you get y equals 2 over x. Now that's looking more like this form over here, because now my y is by itself. So I can identify a as being a 2, h as being a 0, and k is also a 0. All right, so vertical asymptote, again, is your x value. So x is going to be 0, and y is equal to 0. So let's go ahead and graph those things. So x is 0, that's going to be here. Okay, y is 0 is going to be here. Okay, so it didn't really move anywhere. And actually, since I can see right now where my asymptotes are, there's my y, my x equals and my y equals. My graph never touches the x-axis or the y-axis. So since it doesn't touch either one of these, that means I don't have any intercepts. So x-intercept and y-intercept, there's none. So that just saved me a ton of work. So if your asymptotes are lying on one of the axes, go ahead and just take a look at your intercepts, because if it doesn't touch the axes, the axis, x-axis or y-axis, then you're not going to have intercepts with that axis. All right. Okay. Let's go ahead and make our table. Table values. We made it down here last time, but we don't have any of those anyways. So I'll make it up here since we don't have any intercepts to solve for anyways. So my table is going to start where my h value is, which is 0. I'm going to go up a couple and down a couple. When I plug these in, I'm going to get 2 divided by 2, which is a 1. 2 divided by 1, which is a 2. 2 divided by 0, which is not going to work out because that middle point never does. Undefined. Okay. -1, that's going to be a -2. That's going to be a -1. Okay, so when I plug these x values into this, that's what I'm going to get. All right, so let's plot those. So here we go. 2, 1. Let's write 2 up 1. 1, 2. You got -1, -2. You got -2. So -2, -1. There's your points. Go ahead and draw it really close. And then really close. If you notice, that did not ever touch my x or y axis. Same thing with this one. Make them close. And there you go. That's your graph. All right. Just a couple more parts. We just got to identify domain, range, and the transformations. So my domain is all real numbers, but your x cannot be 0. Okay. And then range is all real numbers, except the one y value, which it never touches, which is the asymptote. So it cannot be 0. Transformations, my a value was a 2, h and k were 0, so all that's happening here, it's a positive, so it's just going to be, it's not reflected, it's just going to be stretched. So stretch factor 2. Okay, and that is it. So get that graph. And again, as always, if you have any questions, feel free to stop by during tutorial or office hours, and I can try to help you out. All right, have a good day. Bye-bye.